Okay, so this is the part 3 for the series of lectures for chapter 9, valuing bonds with embedded option. Let's move to the main topic, valuation of bonds with embedded options using binomial model. So the interest rate that are used in the valuation process for this binomial model are obtained from a binomial interest rate tree. The binomial interest rate tree, once we allow for the embedded option, consideration must be given to the interest rate volatility. The reason is the decision of the issuer or the investor depend upon who has the option will be affected by what interest rates are in the what interest rate we have in the future, and we can obtain those using the interest rate tree. Let's see how interest rate volatility is introduced. Let's first see that what we mean by interest rate tree. If you look at this picture, uh, this is a 1 year binomial interest rate tree. So this is today, which we call as a root. And in a binomial model, we assume that interest rate can only take one of the two paths. Either it can go up or it can go down. If it can go up, it will go to R1H. If it goes down, it will go to R1L. If we extend it to the 2 years, at each node, there can be two paths which interest rate can take. Here it can go up or down. From here it can go up or down. So high represents high after high low represents high after low, and similarly it also represents low after high and then low, right? So this is what we represent in an interest rate tree. Let's see the how we have incorporated the volatility here. If we look at the panel A, 1 year, we are showing that from the root interest rate tree can go to the two directions, right? So that is a random event. The dot in the exhibit referred as a node, but then what takes place at the node is either a random event or decision. Here it's a random event. We see that in building a binomial interest rate tree, at each node there is a random event. The change in interest rate represents that random event. In the binomial model, it is assumed that the random event will take only two possible values, as I explained. The probability of realizing either value is equal. So the interesting thing is probability of realizing either value is equal. So 50% chance for each of them. The two possible values are the interest rates shown by R1H and R1L. If you look at the time frame at the bottom of the panel, you will notice it's in years, right? So the time frame is in years. Now in panel B, as I already explained, there are two nodes at year 1, depending on whether higher or the lower interest rate is realized again, and then in turn we will go to the respective direction in terms of the interest rates. We can extend this tree, this particular tree, up to the 4 year, which means up to the consideration we are looking at. Okay, so this is the 4 year binomial interest rate tree. You can see various options, and this is all logical. So here 4 else means this value is got here after 4 low interest rates, right? This is high and 4 low, so it means we got here after 3 low and 1 high interest rate, right? Okay, now let's talk about how to determine the value at any particular node, which is very important. Uh, in order to value a bond, we need to determine the value of bond at each node, right? So until now, we were looking at the interest rates. When we look at the bond valuation, we need the value at each node. Let me show you another exhibit. Let me take a snapshot from the book and show you something. Okay, let me paste it here. Okay, so you can see this. So now, in order to value a bond, we need to determine value of bond at each node. So we have just discussed the value of interest rate at each node. To find the value of the bond at the node, we begin by calculate the bond value at the high and low nodes to the right of the node for which we are interested in obtaining the value. So for example, if we want to calculate value here, first we need to calculate value of a high node and low node. So first we have to determine bonds value here, and then only we will be able to calculate the bonds value here at the root. The process involves starting from the last rightmost tier in the tree and working backwards to get the final solution we want, hence called backward induction. So if we are starting from here, we need to, if we are valuing this particular bond, we need to start from here, right? So that's the backward induction. Effectively, what we are saying is that if we are at some node, the value at their node will depend on the future cash flow, which is the basis of valuation. That value at any time, which is represented by node here, is the present value of future cash flow. The future cash flows in turn depend on two things. One, the coupon payment 1 year from now, and the bonds value 1 year from now. So the bonds value 1 year from now plus what will be the coupon payment. So cash flow at the node will be either bonds value if 1 year rate is the higher rate plus the coupon rate, or the bonds value if the 1 year rate is lower rate plus the coupon. It can only take one of these value, and the bonds value will be is the simple average of those two values, right? So that would discount back these two values and then simply take the simple uh, average of these two values, right? So it's pretty straightforward. Uh, until now, we have discussed these things from the theoretical perspective, but let's talk about how actually to construct the binomial interest rate tree. The construction of any interest rate tree is complicated, although the principle is simple to understand. And the principle is is that when a tree is used to value an on the run issue of the benchmark, the resultant value should be the arbitrage free. What we mean is that the tree should generate a value of on the run issue equal to its observed market value. So if the tree is generating observed market value, then we can say that it's an arbitrage free value, and we can then use those interest rates from the tree to value our embedded option, bond with embedded option. The interest rate at the first node, i.e. root of the tree, is the 1 year interest rate for the 1 year issue, which we already know. The tree is grown just the same way that the spot rate were obtained using the bootstrapping method based on arbitrage argument. And the interest rate for year one are obtained from the following information. So for the year one, we should have the coupon rate for 2 year on the run issue, the interest rate volatility assumed, and the interest rate at the root of the tree, which is the 1 year. So we should have these three things. Giving these things, a guess is then made for the lower rate node NL, which is R1L. So we make a guess for lower rate node. The upper rate R1H is then not guess, but instead is determined by assumed volatility of 1 year. The formula for determining R1H1 given R1L is specified by some interest rate model. Using the R1L, what was guessed and corresponding R1H, the year on the run issue can be valued. For if the resulting value, if using this R1H and R1L, we got if the resulting value uh, computed using the backward induction method is not equal to the market value of the 2-year under an issue, then the R1L that was tried not to rate that should be used in the tree. If the value is too high, then a higher rate guess should be tried. If the value is too low, then the lower rate should be tried. And we use this as a trial and error to obtain the value or the interest rate which should value the security fairly. Same thing can be done to the year 2 interest rate. Here we will need the coupon rate for a 3-year under an issue, interest rate model assumed, interest rate volatility assumed, interest rate at the root of the tree, which is the current 1-year under run rate and 2-year rates, right? So again, we will follow the same process. Now here, remember, because you have to now calculate R2HH, R2LL, and R2HL. We again guess R2LL and using the model try to figure out what is the value for R2HL and R2HH. And we continue this trial and error process until we get the desired value. How can, now the question arises, how can we be sure that the interest rate shown in Exhibit 1 are the correct rates? Again, the verification involves using the interest rate to value on the run security, right? Let's see this graph. This shows the actual interest rate tree based on the up to 4 years, right? So this is a tree which shows 1 year spot rate up to 4 years by assuming interest rate volatility of 10%. We are not going into the calculation of these interest, right? We are just understanding the logic how these come into force, right? So how we verify these interest rates now? We simply verify it by considering our date. Remember, 4-year bond, the 4-year bond, which was 6.5% bond, and if we value it, so its value is 100 here, and at this node we it's a, so basically it's a 4.7% 4-year bond, right? So it's a 4.7% 4-year bond. We have interest rate at each node. So these are the values, and the interest rates at the nodes are 7.053. So we discount this back at 0.53. We will get 97.846, right? So you got 100 and plus 47. You add them up and then you discount back at 7.0053, right? Similarly, if you discount these two back, you will get this. If you discount these two back, you will get this. Okay. So we discount these back at these interest rate, right? And we obtain this value by taking the average of these two values, right? So this value is present value of these two divided by 2, right? And so on. And we can see that the value or the market price of this particular not 4-year, sorry, 3-year bond is 100, right? So as we already said, that if the market price, if value calculated is equal to the market price, then we say that okay, we got the correct interest rate. Okay, now let's see how to value option free bond with this interest rate tree. And remember, we had that particular 6.5% bond for which we in previous video we obtained a price of 1046. So here the face value used is 100, so coupon is 6.5. If you focus here, this is a 4-year bond. It's coupon. So if you calculate this this value, if you want to calculate this value, what you need to do is discount back both of these cash flows plus coupon at 9.1987% and then take its average, right? So for example, if you want to calculate, if you want to verify if this value is correct, what you should do is discount back these two values and then take the average, right? You can see its price is equal to what we discussed, 1046. Here only the difference is the face value used is 100. So you can see that interest rate tree can be easily constructed, and that interest rate tree can be used to value option free bonds. That's all in this video.